combination R, success to power R, failure. So I need to write success the way it should be. All right, success to power R, success to power R, and failure to power n minus R. So this is the binomial distribution formula here. And this is n. N is sample space. R is the number you want to take at a time. In this particular question, R is 4. P is success, is the probability of success. R is the number you want at a time. Q is the probability of failure. And then the exponent of Q is the sample space minus the number you want at a time. Sample space minus the number you want at a time. Okay, so now that I'm given all these things in the question, I can actually substitute that. And by the way, the sample space is 12. So let's just explain what in the world does this question mean. So actually, this question means that I have to cumulate, because it says less than or equal to 4. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I have to cumulate from 4, from here, down to 0. You always count 0. So in other words, I'm told to find the probability of 0, probability of 1, probability of 2, probability of 3, probability of 4. I could be told to make a table out of it. And if I'm told to make a table out of it, I will do so. So let me actually answer that question. All right. So first of all, I want to write it in such a way that if I'm told to make a table out of it, or if I am told to find the make a table, find each individual probability, I will do so. So I will find it in such a way that we do it one by one, and we do it together. That is a formula you can use to do all of them at a time, but there's a formula you can use to do it one by one. So let's so suppose I'm told to show a table, I will do that. So what am I trying to show? Suppose I'm told to do it one by one. In other words, find P0. So it means I'm going to find probability of 0 plus probability of 1 plus probability of 2 plus probability of 3 plus probability of 4. And then to expand the probability of 0, I'll use the formula again. So probability of 0 is sample space 12 combination 0, success to power 0, failure to power 12 minus 0. So this is P0. This is P0 here. Then P1 is the same as 12 combination 1, success to power 1, failure to power 12 minus 1. Then if I'm looking for P2, P2 is the same as 12 combination 2, success to power 2, failure to power 12 minus 2. If I'm looking for P3, I'll do P3 equal to 12 combination 3, success to power 3, failure 12 minus 3. And then I'm going to do 4 because I need P4 also. P4 is equal to 12 combination 4, success to power 4, failure to power 12 minus 4. And then I'll make a table. So I will quickly make a table. In other words, if I'm told to make a probability distribution, a binomial probability distribution table, I can make that out of this question. Even though I'm not told to make it, but some questions can tell you to make it. So I'm making a probability distribution question for what I'm told to calculate. I'm told to calculate the probability of that x is less than or equal to 4. Okay, so what it means, I'm going to put the random variables on the left-hand side. So this is x, random variable 0, 1, 2, 3, 4. Then I'm going to find P0. So P0, and I'll get my calculator though. I'll show you how to do it by calculator. P0, 12 combination 0. So, and probability of x. So I'm going to get my calculator, take it one by one. I'm going to find P0. Okay, and how do I find P0? I get to my calculator, and I'm going to clear, and I will go to second distribution, and I look for binomial. We're not doing normal this time, so we're not going to be looking for normal. We're looking for binomial distribution. So binomial PDF, because I'm doing them individually, one by one. So I'm going to select, and then it asks me number of trials. Number of trials is the sum of sample space. So I select 12. Success, what is success? Success is the probability of success, and I'm told that it is 0.35. Success is 0.35. Okay, so that is 0.35. And what is x? What is the value? I'm evaluating 0 first. 0. When I finish, I'll put my answer in to 4 decimal places. I'm going to hit enter. And by the way, the argument is NPR. NPR. Okay, so to 4 decimal places, P0 is 0.0057 to 4 decimal places. 0.0057. So I'm just going to write 0.00. Let me write it here, 0.0057. And so remember that this is the same as 12 combination 0, success to power 0, failure to power 12 minus 0. And so when I calculate that, I'll get this. Then I'm going to find P1. So I'm going to pull my calculator again. And because it's P1, I can just do second enter, arrow in, and change that to 1. That way I won't waste time. I hit enter, and I'll get 0.0368. 0.0368. So I have 0.0368. So I'm going to get P2. I'll do second enter again. And I'll change 1 to 2 because I am looking for the probability of 2. I'll hit enter. And my answer is 0.1088. So 0.1088. 0.1088. Then I'm going to do P3. And if I arrow down, I will now put 3 where this is. there, and I hit enter. So 0.1954, 0.11954. And then I'll do the fourth one. The question is, what is the probability of accumulating from 4 to 0? So the next one is, I'm just going to get my calculator again and find probability of 4, P4. So P4, if I do second enter, and I'll arrow in, I will change 4, change 3 to 4. And then I'll hit enter. Oh, this is 3. Okay. And then I will hit enter. Okay. It's now 35. Okay. I'm going to go back. Second distribution. And then I'll arrow up and look for my binomial PDF. And then it's 12. And this time it is 4 right there. And I'll calculate. If I hit enter, I have 0.2367. 0.2367. 2, 3, 6. Point 2367 67. All right, so now if I get my calculator and add all 4 of them, I'll get the probability, the total probability. And let me just take my time and add all of them. Let me bring my calculator and add all of them. I already made a table. And the quickest way to do it, you can also be told to find the standard a calculator. So what you're going to do is get your calculator right here, edit, and arrow to L1, clear, L1, enter, clear L2, enter. And in the table you have made, you put in X, the random variables, and put in Y, the probabilities. Okay, so I want to find all these things together. So I can just do 0, enter 1, enter 2, enter 3, enter 4, enter. So that is the random variables. On the right-hand side, I want to put in the individual probabilities. All right, so I have 0.0057, enter. The next one is 0.0368, 0.0368. The next one is 0.1, okay, 0.1088, 0.1088. The next one is 0.1954, 0.1954. And the next one is 0.2367. Okay, and then you see that both of them are the same. So I can do one variable start now and find the mean, median, and find everything. So I'm going to arrow to the right, do one variable start of L1 and L2. My data is correct. So if I'm told to find the mean of that probability, the mean is 3.06 to 2 decimal places. If I'm told to find the standard deviation is 0.963. Okay, because I'm told to find the probability from 4 to 0, that probability, if I add all of them, so I can actually say second weight and I will add all my probabilities. So I will say sum and L2. So where do I see sum? In catalog. So I'm going to be looking for sum and sum, and then I'll keep looking for sum of L2, sum of L2. The quickest way. You can actually do it in a minute, but I'm taking the long way now. You don't have to use this long way, but I'm expected to show you all of them anyway. I have to show you all of them. So sum, and my calculator is asking me, what are you summing? I am summing all the probabilities in L2. I'm summing L2, and I put comma. If I hit enter, I have 0.5834. So the total probability of accumulating from 4 to 0 is 0.5834. So my answer, the probability that I will hit sum 4 to 0 is. Okay, so this is you're expected to know this long way, but let me show you the shortest way of doing it. I can now just go to probabilities. So second distribution, I'm showing you the short way because you don't have to follow all this long way. Because you are accumulating, you just go to binomial cumulative density function. So go to cumulative, and it's asking you how many are there, 12, and then the success is given as 0.35, and the value is from 4 to 0. You're accumulating from 4 to 0, and you paste, and what's your answer? You see that the answer you got from doing the short method is the same as the answer you got from, see, 0.5833, but doing it one by one is longer, but you might be told to do it one by one. So you can use the long method. And let me actually write it. 15833. So our answer, probability that I can accumulate that the random variable x is x less than or equal to 4 is 0.58. 0.5833. Either way, any method you do it, you get the same answer. You use the long method, you get the same answer. You use the short method, you get the same answer. Okay, so this is the probability. Remember, it is the same. This probability of accumulating from 0 to 4 is the same as accumulating P with 0 plus P1 plus P2 plus P3 plus P4. All right. And so when you accumulate all of them, you get probability of less than or equal to 4. All right. I did it the long way. I did it the short way. I hope this, I hope it is clear. If you don't understand, ask me to do it again. I can do it again. The reason why I did the long way is because you are expected to know the long way also. You are expected to know the long way. Okay. So we just did this probability of accumulating from 4 to 0. And this kind of probability is called at most probability. So we just did an at most probability. At most probability is the one we did. At most is less than or equal to. At most implies less than or equal to. Okay, exactly implies equals at least at least greater than or equal to. Okay, so whenever I am doing an at least, so I'm going to actually open my whiteboard because I'm going to open my whiteboard. All right, so now I'm opening my whiteboard. I just want to, okay, that's my template. All right. Okay, so now I am going to use my whiteboard to do number 20. Okay, so we did an at least probability. What if I am given this one? What if I'm repeating number 18? What if we are given 18 that n sample size is equal to 12, success is equal to 0.35, and then we are told to find what is the probability p equal to 4. What is the probability? Calculate the probability that equals to 4, px equal to 4. So this one is called exactly probability. So in this exactly probability, all you have to do is n combination for r, success to power r, failure to power n minus r. You could be told to do it by formula. If you're told to do it by formula, you just plug in 12 combination 4, success 0.35 to power 4, failure, see, failure is 1 minus success. All right, so 1 minus 0.35 is 0.65. So failure, 0.65 to power 12 minus 4, which is 8. So now I can multiply this out without even putting it in calculator. I'm going to do it two ways. I'm just going to do it by multiplying it out. So I'm going to multiply it out, and then I'll turn it on, and I'll clear, and I multiply it out. So I'm just going to do a 12 combination. 4, everybody knows where to find combination. So 12, and I'm going to combination. And where do I see combination? I know I saw combination in math, arrow to P, arrow B, and I see there's 3 and 4. Then I multiply success to power 4. What is success? 0.35 raised to power 4. Failure, which means multiply. I'm going to arrow out. Multiplied by failure 0.65 to power 8. And I hope you know that I can put caret here, caret 8. Right. Okay, if I hit enter, I get the probability. So this probability of exactly 4 is this. Do it also do it by short form. So what I'm going to do is n. Let's see, I am going to find binomial probability binomial PDF. Now N is 12 and PR. P is 0.35 and X, random variable, is 4. So I'll get my calculator and find it. Use my calculator to find. Okay. And then, so how do I find it? Okay, I'll have, I don't have to put the other one. All I have to do is go to binomial, second distribution, go to binomial, and this is binomial PDF. Why? Because I'm looking for a single probability. I'm looking for a single probability. How many? What is the sample space? 12. What is the number of success? Success is 0.35. What is the value I want? I want 4. And I'm going to paste. When I hit enter, see, we have the same answer. So whether you do it with a long method or short method, you have the same answer. And therefore, the binomial, the probability of a random variable is equal to 4 is, I'm going to leave my answer to 4 decimal places. Implies, use implies, it's equal to 0.2367. 0.2367. Let's do that again. Let me see. 0.2367. So this is a single probability. So this is an example of exactly probability. Exactly probability is a single probability. So this is an exactly probability. You do binomial PDF, exactly probability. The one we did before is at most probability. Okay, suppose I'm told to find at least probability. So I'm told to find at least probability. So I'm actually still talking about number 18. Suppose I change the question to what is the probability? Find Px such that probability of x is greater than or equal to 4. Greater than or equal to 4. It means that if I list all of them, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. If I list all of them, what I'm going to do is, because I'm told to accumulate to the right, greater than or equal to. So I'm accumulating to the right now. Another way of saying complements. So we're actually doing complement rule this time. So I'm going to accumulate to the right. So since I'm accumulating to the right, it's actually the same as P. This is the same, okay, as P of X less than 4 complement. Okay, so how do you answer this question? You just, this is equal to, or this implies 1 minus probability binomial cumulative density function, starting from, first of all, it's 12 sample space. Success is 0.35, doesn't change. And because it is less than only, 4 is not included. So 3 is what I'm going to put there. I have to put 3 there because I need a number less than 4. If I put in 4 there, then I have changed the question. So Another way of cumulating from 4 to 12 is doing the prime, the complement of P less the complement. Put it down, let me get my calculator. Okay, so I'll get my calculator. And I'll tell my calculator that I'm looking for the probability 1 minus binomial cumulative density function, CDF. So I go to second distribution, and I'm looking for binomial. And I'm looking for binomial cumulative density function, that is CDF. Okay, how many trials? 12. I'm given that there are 12 of them. What is the probability of success? 0.35. What is the value of X? The value that I'm told to find is that number less than 4, because I'm cumulating down. So it got to be 3. And then I'm going to paste. I hope you know why 4 should not be there. Because if you cumulate from 4, if you subtract 4, then you change the question. All right, so I am now going to hit enter. Therefore, the cumulative, the binomial distribution, finding that you can cumulate from 4 to 12 is a large number, and this is the same as 0.6533. This is approximately 0.6533. You see, none of our answers is more than 1. Because it's probability, your answer is not allowed to be 1. It is probability, your answer is not allowed to be 1. Cannot be more than 1. It cannot be negative. Even though it's called binomial distribution, it is still binomial probability distribution. Binomial distribution is also discrete, just like probability distribution we did last. Okay, so we can now, so we have now solved the problem where we have an at least. An at least problem, whenever you are given at least problem, it means the same as greater than or equal to, and if you're putting it in your calculator, it is 1 minus binomial CDF NPR, and it has to be NPR minus 1. It has to be 1 less than the number mentioned. Yeah, it depends on what the question is. Okay, let's go to number 20. So let's go to number 20, and number 20 to do a lot of examples. We've already said that binomial distribution has only 2 events: success or failure. Success is a probability, failure is a probability. The 2 probabilities must sum up to 1. Success plus failure must be equal to 1. And then you could be told to use binomial formula to solve the problem. So the next one now is go to another number called, I'm going to go to number 12. All right, so I'm going to number 12. All right, number 12. All right, so I'm going to clear because that's a whole lot of things there. But anyway, number 20. So let's look at number 20. Number 20, in number 20 has sample space of 12, but the probability is 0.75. Success is 0.75. So everything is intact except that. So now I am going to ask 3 questions here. So in number 20, a binomial experiment is conducted with the given parameters. Compute the probability of X successes in the independent in trials. Okay, so what I'm going to do is go to my whiteboard. I'm going to whiteboard right now, and I am going to move it out, and I'm going to write number 20 here. So we have a binomial experiment, and in this binomial experiment in number 20, we are given that sample size is still 12. Probability of success is 0.75, 75% success. And we are able to find P11. What is the probability of X equal to 11? Equal to 11. Okay, so that is exactly. So I'm going to say exactly 11. So I can take this out. So what is the probability of P that X is equal to 11? So I'm going to call this one question A. This is called an exactly question. Exactly. All right, because there's an equal sign here. Exactly and equal sign are the same. Exactly and equal sign are the same. And actually, I can rewrite it right here. And I say 12 combination 11 success. And success is 0.75. Success to power 11. And then failure. If success is 0.75, failure is 0.25. And the exponent here is 12 minus 11, and that is 1. So I will get my calculator. I will pick up my calculator. And then, okay, so I want to put this in my calculator. Alternatively, I can do it by hand. But anyway, you don't have to do it by hand because you're allowed to use calculator. So second distribution, look for binomial. And I'm looking for exactly. Why exactly? Because I'm looking for only 12, only 11. What is the probability of exactly 11? You should know when the question is an exactly question. Whenever the question has equal sign, it's an exactly question. When it has less than or equal to, it's an at most question. When it has greater than or equal to, it's an at least question. Okay, so if I hit enter, this is only binomial PDF because it's exactly. You pull up PDF. Then they're asking you what is the sample space? It's 12. What is the probability? 0.75. Which value are you looking for? I'm looking for value 11. Calculate. Tell my calculator to calculate. I've already written the formula, so I can just write my calculate. And so that probability is 0.1267. So the probability that I just get exactly 11 is 0.1267, 0.1267, 0.1267. If my answer is 1 point something, I made a mistake. Anytime you calculate the probability of an event and it is 1 point something, now it is not right. It is not right because the probability of an event cannot be greater than 1. Also, if you calculate the probability of event and it's negative, it's a mathematical fallacy. It's not allowed to be less than 11 or less than 0. Okay, now I'm going to ask another question. What if the question says less than or equal to 11? What is, let's say, B? Let me call this one at most 11. And at most 11 means the probability of x less than or equal to 11. And what does this mean? It actually means if I list all of them 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So if I list all of them, then it actually wants me to find P0 plus P2 plus P3 until 11. Okay? But I can use my calculator. So I can say binomial cumulative density function. Sample space is 12. Success is given to me as 75% of 0.75. And I'm told to start from 11, cumulate down. Okay? Oh, it's very easy. You get your calculator and put that in. And where do you see binomial CDF? Okay, so remember that this is PDF. You cannot use PDF when you are accumulating. Whenever you're answering at most question, you cannot use PDF. PDF is an exactly question. So I'm going to do second distribution. Then I will start looking for binomial. And I'm looking for binomial CDF because I'm accumulating. What is the sample space? Is 12. What is success? The success is given to me as 75%. What is the random variable? The random variable is 11. I have to put 11 exactly because I'm doing at most question. The only time I put a number less than is when I'm doing an at least question. If the question is an at least question. So I'm going to, now it's asking me, is this correct? Yes. So my answer is 0.9683. Therefore, the probability of cumulating from 11 to 0 is 0.9683. 0.9683. So that probability is very high. 9683. Okay. Now I'm going to ask another question. What if the probability says calculate the probability of at most 11. At least 11. At least 11. Okay. And if it's an at least 11, you want to make sure that you are doing complement rule. So you're going to do 1 minus. So you will do, that's what you're going to do here. Because it's an at least question, you have to do at least. So the question says at least. Okay. At least 11. So you're going to do 1 minus binomial cumulative density function. Sample size, success, and the number 1 at a time has to be 1 less than 11. 1 less than 11. So it has to be 10. Why? Because I'm solving an at least question. Actually, if I can count this number 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. The question is asking me to cumulate at least 11 greater than or equal to 11. In other words, these ones are not included. You see, because these ones are not included, that is why I put the number 10 there. Because I'm doing an at least question. Okay, so I'm going to tell my calculator to calculate 1 minus binomial CDF of at least 11. So I'll put my calculator up. Put my calculator up. And then I'm going to clear. I'm going to do second distribution. And I'll arrow up. When I arrow up, I'm looking for binomial CDF. Remember, it is binomial. It is not normal. Sample space is 12 again. Success is 0.75. I am cumulating. I'm doing 1 minus. So I get this. By the way, there should be 10. And when I go to paste, I'll look at what I'm asking my calculator. Remember, I'm supposed to put 1 minus there. So let me see. Is there any 1 minus there? So if not, then I will put it in second insert 1 minus, because this is the way it should be. So now I hit enter. My answer is going to be 0.1584. So the probability of accumulating from 11 to 12 is 0.1584. So 0.1584. You could be told to leave your answer in percent. If you're told to leave your answer in percent, then you have 15.84%. 15.84%. Okay, so we're going to summarize. We said that in binomial distribution, there are only 2 events. The 2 events has to be success or failure, yes or no, true or